solution stoichiometry. We've done stoichiometry. We can do stoichiometry with concentrations as well. So remember, grams to moles to moles to grams. That's the mantra of stoichiometry. That's what we chant. Grams to moles to moles to grams. So there are variations. We could have here liters. Liters to moles to grams. Or we could have grams to moles to liters. We've talked about liters of gases, but now we're talking about liters of solution. The unit factor that we use to convert between moles and volume of solution is the molarity. So this is the unit factor that we use. The mole-to-mole ratio comes from the balanced chemical equation. If you have moles to grams, that's the molar mass. If you have moles to liters of solution, I should probably put solution here, because we don't want to mix this up with gases. Liters of solution. You're going to use molarity. So let's look at this. What volume of 0.230 molar HCl will react with 3.40 grams of sodium carbonate? Equation given. With all stoichiometry problems, you need a balanced chemical equation, and then let's use that to organize our information. So here we have 0.230 molar HCl. Well, let's write that under HCl in the equation here. So 0.230. The capital M, when you write it by hand, write moles over liters. Because then you see that's a ratio, that's a unit factor. And then 3.4 grams of sodium carbonate. So 3.40 grams of that guy. So normally we have grams to moles to grams, right? But what are they asking us for this time? Volume. So we are not going to have grams at the end. We're going to have liters of solution. So we're going to start with this guy, grams of sodium carbonate to moles of sodium carbonate, to moles of HCl, to volume of HCl. 3.40 grams of sodium carbonate. Grams to moles. So moles of sodium carbonate. I know it gets tedious writing all the chemical formulas. Get over it. From moles of sodium carbonate, we want to go to moles of HCl, the thing we're looking for. And then we want to go to liters of HCl, solution. So our units match up with our path, and then we fill in the units at the bottom so that they cancel out. This is going to be moles of sodium carbonate. Those cancel. And then we've got grams of sodium carbonate down here. This mole-to-mole ratio is easy. Comes from the balanced chemical equation. 1 mole of sodium carbonate reacts with 2 moles of HCl. 2 moles of HCl, 1 mole of sodium carbonate. This one's pretty easy too because it was given to us in the problem. 0.230 moles per liter. I didn't leave enough space. Squeeze it in. 0.230 moles per liter. And then how do we get this number? Periodic table. 2 times the mass of sodium plus 1 carbon plus 3 times the mass of oxygen. 105.99. Anybody else get that? No? What'd you get?
Yes.
Yes, okay, good. So that's 1 mole of sodium carbonate. So that goes down here. 105.99 grams to 1 mole. We've got all our numbers in. We can just go straight across. 3.4 times 1 divided by 105.99 times 2 divided by 1 times 1 divided by 0.230. And we come up with, I'll put it up here, 3 significant figures, 0.279 liters. This HCl is aqueous. It's dissolved in water. It's a solution. We could also calculate the mass of HCl that would be needed to react with that amount of sodium carbonate. But because it's already dissolved in water, we'd have a hard time measuring it. And so it's much more convenient, since we know the concentration, to calculate the volume, and we can use a graduated cylinder and measure out what we need. Any questions? I think this is the last one. Yeah, last one. One more example. Given that 27.5 milliliters of 0.210 molar lithium iodide solution reacts with 133 molar lead-2 nitrate solution, what volume of lead nitrate solution is required for complete precipitation? Lots of words in there. Balanced chemical equation. Just realized that looks like Lil. Too Lil. It's a little molecule. Let's take these numbers and write them under what they apply to. So this is the lithium iodide, isn't it? So let's write the numbers under. So we have 27.5 milliliters of that, and we have 0.210 moles per liter is the concentration. Reacts with 0.133 molar lead nitrate, lead-2 nitrate. Well, this one's the lead-2 nitrate, right? That's lead iodide. That's lithium nitrate. So we'll write that over here. 0.133 moles per liter. What volume of lead nitrate solution? Question mark. It didn't specify a unit, did it? What would be easy? Liters? So for stoichiometry, we do grams to moles to moles to grams. But this time we don't have grams to start out with. This is the one that we have a question about, so that means we have to start with this one. We're starting with a volume, aren't we? So we're not starting with grams, we're starting actually with milliliters, which we're going to have to take a little detour through liters to get to moles, but that's okay. And then at the end, we don't want to find grams, we want to find liters. Everybody okay with that? Anytime you're doing stoichiometry, it's always moles to moles in the middle. Okay, so we're starting with this one. So 27.5 milliliters. Do you want to see a trick? Yes or no? Mm-hmm. Yes. Instead of writing milli in there, I can write what it means. Milli means 10 to the minus third. So I could substitute times 10 to the minus third for milli. And look, it ends up being the same thing. 27.5 milliliters times liters on top, milliliters on bottom. Those cancel out. I need to put 10 to the minus third up there. That is the same quantity. If I don't convert it to correct scientific notation, I get the same number. You like that? If that's confusing, do it like this. If you like that, go ahead and use it. So, liters to moles. Moles of what? This was the volume of lithium iodide, Lil. And then I'm going to go to moles of what? PbNO3 Saying what reminds me, I just listened to Abbott and Costello this afternoon. Somebody put up the whole who's on first thing. Who's on first? What's on third? What's on second? I don't know what's on third. It's hysterical. If you haven't ever seen that, or even if you have, you should go listen to it. It's just a riot. And then what's going to come here at the end? Liters. I don't have room, so I'm just going to write liters there. So units. I need liters of the lithium iodide solution. Cancel those guys. And I need moles of lithium iodide down here. Cancel those guys. And this is going to be moles of the lead nitrate. I'm being a little sloppy, I'm sorry. It's the end of the semester. This molarity is for the lead nitrate. Right? This was the lithium iodide. This one's the lead nitrate. And so 1 liter to 0.133 moles. This is the concentration for the lithium iodide. That's this guy right here. 0.210 moles per liter. Mole to mole ratio from the equation, 1 mole of lead nitrate to 2 moles of lithium iodide. 1 of these to 2 of those. 27.5 EE minus 3. Even though that's not standard scientific notation, your calculator can handle it. Times 0.21 divided by 2 divided by 0.133 equals 0.0217 liters. That's kind of a small number of liters, isn't it? What would that be in milliliters? 21.7. And to do that, you just use your units and convert. Those are the same amounts, just in different units. Any questions? Let's go home.